Hello, this is Mrs. Decker, and this is Objective 1D. I can explain what allows substances to be able to dissolve in other substances. Whether a substance can dissolve in another substance is very dependent on whether the substances are polar or nonpolar. So we want to go back and refresh our memories as to what polar and nonpolar means. Remember, polar compounds do not share their electrons equally, so the molecule has a charge. One example of a polar compound would be an ionic bond. Remember, ionic bonds are not sharing electrons at all, they are transferring them from one element to another. So the metal is giving up electrons and it will have a positive charge. The nonmetal is gaining electrons, so it will have a negative charge. So these are full charges on each element, and they form this crystal structure where the charges line up next to each other like this. This example is NaCl. We also have polar covalent compounds where electrons are shared, but they're shared unequally because the one element has a higher electronegativity than the other element. So in this case, oxygen has a larger electronegativity than hydrogen. So the electrons are held closer to the oxygen than they are to the hydrogens, giving the oxygen a slightly negative charge and the hydrogens a slightly positive charge. So two things that are polar are ionic compounds and polar covalent compounds where the electrons are shared unequally. And nonpolar compounds are compounds that do share their electrons equally, so the molecule does not have a charge on any specific part of it. Examples of nonpolar compounds are nonpolar covalent compounds, where electrons are shared equally because there is no large electronegativity difference between the different molecules. An example of this would be oil. Oil is a nonpolar covalent compound where the electrons are all shared equally between the different atoms. So when you put a polar solute in a polar solvent, the solute will dissolve because both the solute and solvent are polar. So this picture is an example of sodium chloride salt being put into water and how water dissolves the salt. The partial negative charge on the oxygen molecule is attracted to the positive charge on the sodium atom. So the oxygen molecules in the water will pull off a sodium atom and then surround it. The same thing will happen with the hydrogen. The partial positive charges on the hydrogen molecules of the water will be attracted to the negative charge on the chlorine atoms. So it will pull a chlorine atom apart and all of the hydrogens will surround it. So the water will do this, pulling apart the salt molecules until they are all surrounded the way that you see in the picture, and the salt is dissolved. You can also dissolve a nonpolar solute in a nonpolar solvent. So even though there are no partial charges on nonpolar compounds to attract them together, there are other weaker forces that attract different molecules that are nonpolar to each other. So those weak intermolecular attractions of a nonpolar solute will be overcome by slightly stronger attractions for the nonpolar solvent, and that causes the nonpolar solute to dissolve in the nonpolar solvent. However, putting a polar solute in a nonpolar solvent will not lead to the solute dissolving. The solvent cannot break apart the intermolecular attractions of the solute because the solute has these strong positive and negative charges towards each other, and the solvent has no even partial charges on them to break apart that strong positive negative attraction. So polar solutes in nonpolar solvents will not dissolve. The same is true for nonpolar solutes will not dissolve in polar solvents. So this is where the phrase like dissolves like comes from. If the solute, the solid, is polar, it will dissolve. It is soluble in a polar solvent, but it is insoluble in a nonpolar solvent. If the solute is nonpolar, it is insoluble in a polar solvent, but it will dissolve in a nonpolar solvent. And then we have ionic bonds, which are also considered polar. So they will be soluble in polar solvents, but they will not be soluble in nonpolar solvents. So now it's your turn to explain why salt will dissolve well in water, but will not dissolve in oil. You need to explain why using your own words, and you might want to use some drawings to help you. But this is the type of question that you will need to be able to answer for this subjective. So go ahead and work on this explanation and let me know if you need some help.